Hey guys, today we're going to talk about scientific data analysis and how scientists analyze data to understand our world and come up with solutions to problems. So let's get started. When it comes to scientific data analysis, normally there is a problem, and scientists look at the problem or observe the problem to make sense of what is going on. So, say we're talking about the problem of global warming, which is a very important issue currently that is going on in the world. And we are currently facing the issue of the world heating up and we're getting heat waves and lots of climate factors that are affecting us globally because of global warming. So, observation is the first step, and it is the data that scientists collect through senses or instruments. It's what you're seeing. So, for an example, would be an observation could be global temperatures have risen by 1.2 degrees Celsius since the 19th century. That's an observation and a real observation that scientists can make based on just senses or instruments such as a thermometer. And next, based on the observations, scientists can make a claim. A clear claim is a clear statement on what you think might be happening. So, if we know or observe that the temperatures are rising by 1.2, have risen by 1.2 degrees Celsius since the 19th century, we can maybe make a statement about what might be happening by saying, well, human activities may be causing the rise in the global temperatures. And this statement can help you experiment and figure out whether your statement is true and even to prove your statement with evidence or even refute that statement with evidence so you can make new statements or new claims. So, the next thing to do after you make a claim based on your observations is back up your claim with evidence, scientific evidence. And a lot of scientific evidence is data collected from sources or experiments or other research papers that can be used to support the claim. Um, so, an example could be you made the claim human activities caused a rise in global temperatures, and say a piece of evidence could be this graph that you have right here. And you can see that as temperature is rising since 1880 towards 2020, carbon dioxide levels have also been rising. So they may be correlated. They may have a relationship with each other. So, an evidence could be the global temperatures has risen by 1.2 degrees Celsius as CO2 levels increased since the pre-industrial era. You could also just say, based on the graph, as global temperatures have increased, CO2 levels have also increased. Now that you have the evidence to back up your claim, you should provide reasoning to connect your claim to your evidence. So, reasoning is the explanation of how the evidence supports your claim, and this is where you bring in prior knowledge. In real life, scientists use prior knowledge from other research papers, from other scientists, other experiments that are well known, and peer reviewed data as their prior knowledge to connect it with the new knowledge that they're finding based on their experiments. So for us, we can in this example we can say CO2 traps heat, which leads to global warming as their concentrations increase. We know that carbon dioxide is one of the greenhouse gases and they trap heat, causing the temperatures to rise. That's prior knowledge that scientists have based on previous experiments, and that can be used to make try to understand your claim and evidence, provide a reasoning. Finally, you make an inference. An inference is a logical conclusion drawn from your evidence and prior knowledge that's beyond the immediate data to suggest possible explanations, relationships, or future outcomes. So, inference is beyond the data that we have. In this case, we have this data. Based on this data, what are some patterns we can find? What are some patterns we notice? What are some predictions we can make based on the outcome? So, you're making a scientific explanation, relationship, or future outcomes based on what you're seeing and the evidence you have. So, in this example, we can say if emissions continue to rise, global warming will worsen, causing severe climate impacts. So, I see that there's a pattern of temperatures rising, so maybe it will continue to rise because we are still emitting lots of carbon dioxide. So, that's the prediction or the inference that we can make. We can also infer that it can be causing severe climate impacts because we're seeing it today already. As the temperatures are rising, we're getting lots of hurricanes, even droughts in some areas, and that can be severe. So this is data that this is beyond the immediate data that's given to you, and you're using prior knowledge and evidence from prior knowledge to find relationships, provide explanations, make predictions, and find patterns. That's it.